ground fault circuit interrupter, often called a GFCI, is an electrical safety device required in specific locations of residential wiring. These locations include bathrooms, kitchens, garages, outdoor areas, and crawl spaces. The primary purpose of a GFCI is to protect people from electrical shock. It achieves this by constantly monitoring the electrical current flowing through a circuit. The GFCI looks for any imbalance between the incoming current and the outgoing current. An imbalance indicates that some of the current is not flowing along its intended path. Instead, it may be leaking to ground, which is a dangerous condition known as a ground fault. Ground faults can occur when electricity escapes its intended path and flows through unintended paths. This could happen, for example, if a person touches a live wire or if an appliance has damaged insulation allowing current to leak. If a GFCI detects even a slight imbalance in current, it quickly interrupts the circuit. This interruption happens within milliseconds, which is fast enough to prevent a dangerous electric shock. The GFCI works by comparing the current in the hot wire with the current in the neutral wire. In a properly functioning circuit, these currents should be equal. If there is a difference of more than a few milliamps, the GFCI trips, cutting off the power. There are two main types of GFCIs: receptacle type GFCIs and circuit breaker type GFCIs. Receptacle type GFCIs are installed in place of standard electrical outlets. They have a test button and a reset button on the face of the receptacle. Circuit breaker type GFCIs are installed in the electrical panel. They protect the entire circuit, including all outlets and devices connected to it. GFCIs are particularly important in areas where water and electricity are likely to come into contact. Water is a good conductor of electricity, so the risk of electric shock is higher in wet locations such as bathrooms, kitchens, and outdoor areas. Firstly, in bathrooms, GFCIs are required for all receptacles. This includes receptacles near sinks, bathtubs, and showers. Secondly, in kitchens, GFCIs are required for all receptacles serving countertop surfaces. This is because countertops are often wet, and appliances such as toasters and blenders can easily come into contact with water. Thirdly, in garages, GFCIs are required for all receptacles. Garages are often damp and may contain tools and equipment that could cause electrical hazards. Fourthly, outdoor areas require GFCI protection for all receptacles that are readily accessible. This includes receptacles on patios, decks, and in gardens. Exposure to rain and moisture increases the risk of electric shock outdoors. Fifthly, crawl spaces require GFCI protection for all receptacles. Crawl spaces are often damp and may contain exposed wiring or plumbing, increasing the risk of electrical hazards. When installing a GFCI receptacle, it is important to follow the manufacturer's instructions carefully. Firstly, turn off the power to the circuit at the circuit breaker. Secondly, remove the existing receptacle from the electrical box. Thirdly, identify the line wires, which are the incoming power wires, and the load wires, which are the wires that continue to other outlets or devices. Fourthly, connect the line wires to the line terminals and the GFCI receptacle and connect the load wires to the load terminals and the GFCI receptacle. Fifthly, ground the GFCI receptacle to the grounding wire in the electrical box. Sixthly, carefully push the GFCI receptacle into the electrical box and secure it with screws. Seventhly, install the cover plate. Eighthly, turn the power back on at the circuit breaker and test the GFCI receptacle by pressing the test button. The reset button should pop out indicating that the GFCI is working correctly. If the GFCI does not trip when the test button is pressed, there is a problem with the wiring or the GFCI receptacle itself. A circuit breaker type GFCI is installed in the electrical panel in place of a standard circuit breaker. Firstly, turn off the main power to the electrical panel. Secondly, remove the existing circuit breaker from the panel. Thirdly, connect the GFCI circuit breaker to the panel's bus bar into the circuit wires. Fourthly, turn the main power back on and test the GFCI circuit breaker by pressing the test button. The circuit breaker should trip, indicating that it is working correctly. GFCI should be tested monthly to ensure that they are functioning properly. To test a GFCI, press the test button. The reset button should pop out, indicating that the GFCI has tripped. To reset the GFCI, press the reset button. If a GFCI trips frequently, it may indicate a ground fault in the circuit. In this case, it is important to identify and correct the cause of the ground fault. This may involve inspecting appliances, wiring, and other electrical components for damage or defects. It is also important to note that GFCIs do not protect against overloads or short circuits. Overloads occur when too much current is flowing through a circuit, which can cause the wires to overheat and potentially start a fire. Short circuits occur when there is a direct connection between two wires, which can cause a large surge of current and damage to electrical components. Circuit breakers and fuses are designed to protect against overloads and short circuits. These devices interrupt the circuit when excessive current is detected, preventing damage to wiring and equipment. While GFCIs primarily protect against ground faults, arc fault circuit interrupters, or GFCIs, protect against arc faults. Arc faults are dangerous electrical conditions that can cause fires. They occur when electricity jumps between two conductors, creating a spark. GFCIs detect these arcs and interrupt the circuit, preventing fires. GFCIs are often required in bedrooms and other areas where there is a high risk of fire. It is important to understand the difference between GFCIs, circuit breakers, and GFCIs, as each device provides a different type of electrical protection. GFCIs protect against ground faults, circuit breakers protect against overloads and short circuits, and GFCIs protect against arc faults. Using these devices together provides comprehensive electrical protection for homes and buildings. When working with electricity, it is important to take precautions to avoid electric shock. Firstly, always turn off the power to the circuit before working on any electrical components. Secondly, use insulated tools to prevent contact with live wires. Thirdly, wear rubber gloves and shoes to provide additional insulation. Fourthly, never work on electrical equipment when you are wet or standing in water. Fifthly, if you are not comfortable working with electricity, hire a qualified electrician to do the work. The electrical work can be dangerous, and it is important to take the necessary precautions to protect yourself and others from harm. The National Electrical Code, or NEC, provides detailed requirements for the installation of GFCIs and other electrical safety devices. It is important to follow the NEC requirements to ensure that electrical systems are safe and compliant. The NEC is updated every 3 years, so it is important to stay up to date with the latest requirements. The NEC specifies the locations where GFCIs are required, as well as the types of GFCIs that are acceptable. It also provides guidance on the proper installation and testing of GFCIs. Local building codes may also have additional requirements for GFCIs. It is important to check with the local building department to determine the specific requirements in your area. Proper grounding is essential for the effective operation of GFCIs. The grounding system provides a path for fault current to flow back to the source, allowing the GFCI to detect the imbalance and trip the circuit. A properly grounded electrical system also helps to reduce the risk of electric shock by providing a low impedance path for current to flow in the event of a ground fault. Grounding systems typically consist of a grounding electrode, such as a ground rod or a metal water pipe, connected to the electrical panel with a grounding wire. All metal enclosures and equipment should be bonded to the grounding system to ensure that they are at the same potential as ground. Regular inspections of electrical systems can help to identify potential hazards and prevent electrical accidents. Inspections should be performed by a qualified electrician who can identify and correct any problems with the wiring, grounding, or other electrical components. Inspections should include checking for damaged or frayed wires, loose connections, and overloaded circuits. It is also important to test GFCIs and GFCIs regularly to ensure that they are functioning properly. Electrical safety is a critical concern for homeowners and building owners. By understanding the principles of electrical safety and taking the necessary precautions, it is possible to reduce the risk of electrical accidents and protect people from harm. The installation and maintenance of GFCIs are essential components of a comprehensive electrical safety program. GFCIs provide a valuable layer of protection against electric shock in areas where water and electricity are likely to come into contact. By following the NEC requirements and local building codes, it is possible to ensure that GFCIs are properly installed and functioning effectively. When choosing a GFCI, it is important to select a model that is listed by a recognized testing laboratory, such as Underwriters Laboratories or UL. UL listing indicates that the GFCI has been tested and meets certain safety standards. It is also important to choose a GFCI with the appropriate amperage rating for the circuit that it will be protecting. The amperage rating should match the amperage rating of the circuit breaker that protects the circuit. Installing GFCIs is a relatively simple task that can be performed by a homeowner with basic electrical knowledge. However, if you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. The cost of installing GFCIs is relatively low, especially when compared to the potential cost of an electric shock injury. Investing in GFCI protection is a wise decision that can help to protect your family and your property from electrical hazards. In addition to installing GFCIs, there are other steps that you can take to improve electrical safety in your home. Firstly, replace any damaged or frayed wires. Secondly, do not overload electrical outlets. Thirdly, use surge protectors to protect electronic equipment from power surges. Fourthly, keep electrical appliances away from water. Fifthly, teach children about electrical safety. Sixthly, have your electrical system inspected regularly by a qualified electrician. By taking these steps, you can create a safer electrical environment for yourself and your family. Remember, electrical safety is not something to be taken lightly. By understanding the risks and taking the necessary precautions, you can protect yourself and others from the dangers of electricity. The information provided here is intended for general guidance only and should not be considered a substitute for professional electrical advice. If you have any questions or concerns about electrical safety, consult with a qualified electrician. They can assess your specific situation and provide you with tailored recommendations to ensure the safety of your electrical system. Staying informed and proactive about electrical safety is the best way to prevent accidents and protect your home and family.